Okay, welcome to Mr. Max class. All right, so this says geometry notes number 4, but remember, I made these last year with a book that really sucked, and so when we have a book that doesn't suck, which is yours, we have to do them in different orders. And sometimes I also just call notes 4, 4, and call notes 5, 4 as well. Sorry, that was my bad. Numbers are hard, we know this. All right, so today we're learning about angles, angle bisectors, and the angle addition postulate. So before we begin, does anybody have any idea what an angle is? Wonderful, excellent. Does anybody have any idea about an angle bisector, what that might be? Take a guess, a conjecture, if you will. What does it mean to bisect? Divide. Sect means to divide, right? Sectum sempra, thinking Harry Potter here, right? Blood gets everywhere, totally a children's book. Bisect means to cut into two specifically, right? We can also have trisect. That's a really interesting problem. How do you trisect an angle? Greeks were stumped by that for a long time. Chinese weren't. Turns out origami. Origami, who knew? Angle addition postulate. Postulate means it's something we believe we accept, right? It's a foundation for what we do. At some point it comes down to faith. The angle addition postulate, what do you think that's going to be? We know the segment addition postulate, right? You add up the pieces and it gets the whole thing. Remember that? Remember that awful quiz that you guys all hated and you're like, how does it work? And then eventually it clicked and you're like, oh yeah, the pieces add up to the whole thing. Well, the angles are going to add up to the whole thing. That's the idea, okay? Addition postulate. So what is an angle? A figure formed by two rays, hi Ray, that share the same endpoint known as a vertex. So lots of vocab here. The two rays are referred to as the sides of the angle. So words are hard, math is easy. So check it out. Right here is an angle, the thing in purple, okay? So check it out. We have a point that they connect on. That's the vertex. We call that vertex K. It's just what we do. These right here are 2 points on a ray. So we have ray KJ and we have ray KL. Okay? And they intersect at the vertex. And that's the whole thing right there is the angle. This has lots of names. It's good to be able to name stuff, right? So we can call it by its vertex. We can call it angle K, which everybody likes because that's really simple. However, if we had another ray coming off of here, we'd have multiple angle Ks, right? So we need other ways to identify it. We can call it by its points, which is probably the best way because there's no confusion here. Angle JKL, JKL. Notice the vertex is always in the middle. So if we call it JKL, wonderful. We call it LKJ, wonderful. If we call it KJL, no, that's not it. Okay? Vertex is in the middle. You get it? You smell what I'm stepping in? Wonderful, because I guarantee the easiest question on the test on Friday will be, name that angle. And someone will say, angle KJL. And I will cry on the inside. Just kidding, I don't have tears. I don't cry. I have no emotions. We can also call it by number. So this is angle 1. You don't see that very often. Okay? Not very often, but it does come up. So measuring an angle. The measure of an angle tells how the two rays intersect at the vertex. And circles can be thought of as containing all possible angles around its center. But how we divide the circle from its center via its radius can define angle measurement. Words are hard, math is easy. Let me talk to you about this, okay? So here's a circle, okay? You've probably seen one of these before. And that's okay if you have, okay? It's okay. This is a circle. It has a radius, right? How far it goes out from the center, and it's equidistant, all those points. So if we divide up this circle, we create different angles. So check it out. If I divide the circle into quarters, I've created 4 90-degree angles. Well, if a circle contains 1, 2, 3, 4 90-degree angles, how many degrees in a full circle? No scope, right? 360. We need to watch that video with Snoop Dogg. It's going to have to happen. Not live, though. I would get fired for that. What video you ask? I don't know what you're talking about. I would never recommend that for a student to watch. Units of angle measurement, page number 2. Degrees, like 98 degrees, which was that one boy band in the 90s that sang that one Mulan song, right? So one method of breaking down the possible central angles of a circle is dividing the circle into 360 distinct parts. So they take a circle and we divide it up, right? That's going to be angle measures. One way to do it, the one you're probably most familiar with, is degrees, right? And degrees are when you divide a circle up into 360 degrees, okay? 360 parts. So a quarter of the circle is 90, right? Because a quarter of 360 is 90. An eighth of the circle is 45, right? See how I took a quarter and cut it in half? Another way to divide it up is into 30 and 60, or 30, 30, 30. Or you could divide it up into ones, right? 360 ones. Divide it up however you want. Now, why do you think they chose to divide it up into 360? Why not like, I don't know, 180 or, you could divide it up however you wanted. Why are degrees 1/360th of a circle? Any idea? What's magical about the number 360? Other than it's fun to say. Huh? You see what I'm saying? Like, why did they choose a degree to be a 1/360th of a circle? Why not 1/720th? I want to show you something. So, when we divide up something, right, it's usually a good idea to have a number that's easily divisible. So, like, if I had a circle and said that, hey, the whole thing is 3 all the way around, well, then it'd be really easy to make thirds, right? Because if you did that, you'd have 1, 1, and 1 piece. But, like, what if I wanted to divide it into quarters? Well, if I divide it into quarters, that would be 3/4, 3/4, 3. Do you see how that's kind of weird? Right? We want to avoid fractions because we're already talking about fractions. And you're telling me a quarter of circle is going to be 3/4? Wait, what? Right? That's kind of weird. So we wanted a number that's really divisible. And how do we get numbers that are really divisible? Well, you want it to be able to divide it in half, right? That would be useful. We also probably want to be able to divide it into thirds. We probably also want to be able to divide it into, well, fourths we can get for free if we can divide it in half, I guess. So fourths maybe, right? We want to be able to divide it into maybe sixths. That would be good. Be able to divide it into et cetera, et cetera, et cetera. So what I'm saying here is that 360, if we write it out with its factors, well, it's divisible by 2, right? So we can divide it in half. We can also divide that further into thirds, right? Or we can divide that further, even, into sixths. Or we can divide that further into fifths. So all the factors right here, we have 2 squared times 3 times 5 times 6. It's a highly divisible number, right? You can divide it into half, you can divide it into fourths, you can divide it into thirds, you can divide it into fifths, you can divide it into sixths. So it's highly divisible. We can also divide it into 12, right? Because 2 times 6 is 12. We can divide it into 15 different pieces, so it's really divisible. So they picked a number that has lots of factors. Okay, that's the idea. So I'm glad you asked that question, Courtney. Radians. There's another way to divide up the circle, not just degrees. Maybe you've heard of radians. Okay. Oh no. A less common but far more descriptive way of describing the central angles of the circle. That's what radians are. Pop quiz. Circumference of a circle is equal to what? The what? The distance around it. Yes, it's just another way of saying perimeter, right? Squares have perimeter. Triangles have perimeter. Circles have circumference for some reason. I don't know. It's still perimeter. What's the formula, though? Do you know?
It's like pi r something.
Pi r something, exactly. One of them is pi r squared, right? That's the area, because area is always squared. That's how I remember that. The other one is 2 times pi times r, otherwise known as diameter times pi. So 2 times pi is the circumference when the radius is 1. Right? If r is 1, then 2 times pi is c. So what we do is we take the whole circle and we call it not 360 degrees. We call it 2 pi, like Tupac, right? And then we divide that up. Now what's cool about this? Well, if the whole circle is 2 pi, the whole thing's 2 pi. What's half of the circle? 1 pi, right? Oh, that's nice. Well, here's 2 pi. What's a quarter of the circle, then? Nope, not a fourth. It'd be nice if it was, wouldn't? You're a Taoist. I don't mean the religion, or do I? A half, right? Now it's confusing. A quarter of the circle is half, right? But it's not that bad. It makes sense, right? The whole thing's 2 pi's. So half is going to be pi. A quarter is going to be pi over 2. Whole thing's 2 pi. Oops. What do you want to do next? Ignore that. What's a third of the circle? Piece. The whole thing's 2 pi. Pi over 3 would be nice. That'd be a good guess. But pi over 3 is when we cut this into thirds. You see what I'm saying? You dig? Let me see that. So it's not pi over 3. The whole thing divided up into thirds. Yeah? 2/3 pi. Another way to write that is 2 pi over 3, which I like better because it's literally saying take the whole thing and divide it into 3 pieces. Do you see how the bottom is just whatever you want? It's kind of nice. That's radians. And it has to do with the circumference of a circle if the radius is 1. Turn the page. Here we are. This is what we wanted. This is what the people wanted. This is geometry, right? Remember in 5th grade when you learned about this stuff, acute, and you're like, oh, that's cute, because it's little. Huh. And then right angles and obtuse angles. We got more for you, so buckle up. Acute angles. What does this say? What does this say? First of all, that's the angle symbol. It's where it's flat against the line, right? Okay, see how that's flat in the bottom? These are less than signs. So this is saying the measure of angle A, not just angle A, because angle A is a figure. The measure of angle A, whether in degrees or radians, whatever you want to talk about, right? Here we're talking degrees. The measure of angle A is between 0 and 90. That's how you read that. If I said 0 is less than measure of angle A is less than 90, you'd have no idea what that means, right? That's a bunch of mumbo jumbo. It doesn't sound like English. It sounds like math. Read it in English. The measure of angle A is between 0 and 90. Between 0 and 90. Now, does it include 0 and 90? What if measure A was 90? Would it be acute? No, it'd be 90 degrees. It'd be a right angle, right? So it's between 0 and 90, but not including those. Does that make sense? It's like saying I'm thinking of a number between 1 and 10, can't be 1, can't be 10, right? I'm thinking of a number between 0 and 90, can't be 0, can't be 90. That's an acute angle. Another way to say that is non-inclusive, okay? So measure of angle A is between 0 and 90, non-inclusive. That's a little more mathy, right? But it's a lot better than 0 is less than measure of angle A is less than 90, right? Measure of angle A is between these two. That's how we say that. Again, right over here. Right angles are 90 degrees exactly. So measure of angle A equals 90. I'm not thinking of a number between 0 and 90. I'm thinking of an exact number. I'm thinking of 90. What's my number, right? It's not a very exciting question. Right angles. Obtuse angles. Obtuse are between 90 and 180. Now, is it including or not including 90 and 180? Not including, because if it was 90, what would it be? It'd be a right angle. If it was 180, what would it be? A straight angle, which leads us to our next point. Straight angle. Measure of angle A is 80, or 180. So again, we have between 0 and 90, acute, exactly 90, right. Between 90 and 180, obtuse, exactly 180, straight. Do you see the pattern here? Right? We have a range of things, and then we have the exact thing. A range between 0 and 90, exactly 90. A range between 90 and 180, exactly 180. What do you think is coming next? A range between 180 and something. Now, you might think 180 and 270 because we're going up by 90s, right? No. Between 180 and 360. This is what we call a reflex angle. Notice that I'm measuring this angle the long way because it's bigger than 180, right? It's going to be the long way. Notice that a reflex angle is just made up of two parts. This part, which is the reflex, and then the acute angle, right? So we have something that's bigger than 180 and something that's less than 180. Now that angle there might not always be acute because, like I said, it has to be less than 180, so it could be another 90. It could be obtuse. Well, I guess it can't be obtuse, but yes, it could be obtuse. This is the big part. The big part is the reflex angle. So if you go back to here, there's a reflex angle right there, right? There's also a reflex angle here. It's just the big way of measuring it. Same thing here. Questions on that? Reflex angles are huge. It's like a hyperextension almost of your arm, if you've ever done that before. There's one more that's not on here, right? What's the pattern? What's the next thing we need? We have a range between 0 and 90. We have exactly 90. We have a range between 90 and 180. We have exactly 180. We have a range between 180 and 360. Exactly 360. You know what we call that? A revolution. Too much of the money in this country is going to the 1% of the population. Do I sound like anybody? Okay. A revolution. That's what we need in America. All right. The angle addition postulate. What is that? Is that ray? Is that line? What is that? What is it? Ray. Thank you very much. Hi, Ray. Ray, QS, is in the interior. What does it mean to be in the interior? You interior design majors, HGTV addicts. Oh, that's not how you pronounce that. Addicts. My bad. What does interior mean? You what? Inside voices, please, right? Inside. Of, what is that symbol? Less than PQR? Angle, thank you very much, PQR. Then the measure of angle PQR equals the measure of angle PQS plus the measure of angle SQR. Words are hard, math is easy. If we have an angle that's in the interior inside another angle, well, then the two little angles add up to the big one. So check it out. Check it out. So we have interior angle here, and we have an interior angle here, right? So those two angles should add up to the big angle. Do you see it? This guy plus this guy adds up to the big one. You dig? So they say if QS is in the interior, that's Q. QS is in the interior. See how that ray is in the interior of this big angle? Then that means we have the angle addition postulate. The two little angles add up to the big one. Can we prove this? No, it's a postulate. We just believe it. How could it be anything else? All right, classifying by sum. So now we're comparing two angles. Right before it was just like, that's an acute angle. He is acute. Has nothing to do with anybody else. He just is, right? These are in comparison. So complementary angles. Complementary angles add up to 90. So they sum to 90. So two acute angles will add up to 90 degrees. If they do, they're complementary. Supplementary angles. Angles that add up to exactly 180. Smell when I'm stepping in, sound familiar? Wonderful. Okay, here we are. Next page. Angle bisector. It's what the people have been waiting for. The new thing, right? Not the old stuff. We already got the old stuff, the familiar. Angle bisector. Bisect. Cut in half, right? So here's an angle. Angle JKL, or LKJ if you wish, right, is bisected by ray KM. Why? Because look, it cuts it into two equal pieces. How do I know that? Because I have an angle measure here and an angle measure there, and they both have a tick mark, which means they are congruent, which means they have the same angle measure. So JKM and MKL are angles that have the same measure, because it's an angle bisector. So again, ray KM, that guy right there, is an angle bisector of angle JKL. Which means, therefore, right, my favorite symbol, measure of angle JKM is equal to the measure of angle MKL. Now, there's another way to write this. I wasn't able to show this before because the book last year was dumb. And they don't introduce congruency until later, even though they talked about it. So check it out. The angle measures are equal. So give me an example of an angle measure. Any. Give me an angle measure. 9 degrees. Okay, so pretend they're both 9, right? 9 equals 9. That makes sense, right? Numbers equal numbers. Now, this is not talking about the measure. It's talking about a figure, right? The angle itself is congruent to the other angle, not equal. Numbers are equal, figures are congruent. You smell when I'm stepping in? There's a difference, okay? Am I going to be pedantic about it? Maybe. Maybe. I'll probably slip up from time to time and say equal or congruent interchangeably. But figures are congruent, measures are equal. If you're doing an official proof, okay, you're trying to get your master's here, your doctorate, measures are equal because those are numbers. Figures are congruent because they're figures. Questions? No? Wonderful. Excellent. Fantastic. You thought we wouldn't get through all the notes. Well, guess what we did? Your homework is this. Okay, I got a little worky sheety for you. Okay? It is one page, front and back. We're talking a number of questions. Okay? Unspecified. But not too many. I think you'll like it. Tomorrow, we're going to be taking angle measures to the extreme. We're going to be talking about polygons and stuff. Here you are. This should be the easiest homework assignment of the year. And it's not, that's okay. I'm talking, right? I want to make sure it is easy for you. I'm not saying it will de facto be easy, but that it can be. Here you are. This will be the stuff that's new on the test for Friday, and then tomorrow we'll have a little bit more that's going to be on the test, okay? But this week is not a lot to add on before a test. When I can, I try to make sure that the stuff that's brand new right before a test is some of the easiest stuff in the chapter, right? Which makes sense, because you have the least amount of time to learn it before you do that test. I could, in theory, give a quiz on this, and then next week give a test with all of it together, but I think that's a giant waste of time. Like, it would be nice to have another week to digest, I suppose. But, like, time is already short enough as it is. So number one, it says draw the angle with the given name and then label it. Pop quiz. Which one of these letters is the vertex? B. I don't care whether you do A on top and C on the bottom or vice versa, but B has to be the vertex. So that's a thing. Notice that this has revolution. A revolution, right? Mr. Sanders. So you need to define that. It's not in your notes. Okay? This page is all about the angle addition postulate. So yeah, they're going to ask you, hey, what's that angle? And you'll be like, oh, it's 30, right? But they're also going to ask you, like, what's the big angle, BAF? Well, to figure that out, what are you going to have to do? You add up the pieces, right? For some reason, people like angle addition postulate a lot more than segment. But that's it. Tomorrow we'll have another one of these examples, but it'll have letters in it. Oh no! Oh no! It'll be fine. Lainey, don't cry. It's gonna be fine. She's okay, YouTube. Thoughts and prayers for Lainey. Hashtag Lainey 2019. Then I have this question, which tells you to extend ray AF backwards. Haha, AF. What? Stop judging me, Lainey. Trying to start a GoFundMe for you. Right. She need money. She's not poor. She just wants stuff. What?
Number 3.
That.
Measure of angles to AF.
Okay, so actual number 3. Yeah.
When you add those up, it's 90.
Isn't that annoying? Because it doesn't look like 90, does it? Life lesson, kids. It's not drawn to scale. It almost never is. Unless it tells you. Isn't that annoying? God, Mr. Mac, what's wrong with you? I don't know. I just like to watch the world burn. And all the edgy kids in here are like, oh yeah, Dark Knight. I identify with the Joker. Michaela, did you ever, or do you plan to ever dress up as the Joker for Halloween? I feel like that's the kind of edgy that you are.
A Joker?
Yes, like, no, not Heath Ledger Joker. I'm being sarcastic here. You're edgy, but I don't think in that way. Which is more than fine. Questions, comments, concerns, other than for my health? Mental stability, yes. Number 2, like the actual number 2? Okay. State all 4 names for the given angle. And then state the 2 rays. Don't forget that either. So one of the rays is ray XY, right? There are 4 ways to name this angle. Look in your notes if you're confused. I'm trying to give you a hint without just giving you the answer, and it's hard. So look at the example in there. Should be page 1. Ta-da! 4 different ways to name it. There's an or there, so it's 4, not 3. Right? Remember, your angle is XYZ, not JKL, so just literally copy down the notes. That's it, guys. That's it. That's angles. Tomorrow we'll step it up a little bit. Talk a little bit about radians. Just a smidge, maybe. Just a smidge. We didn't do a warm-up today. That's why we have so much time. Forgot to do a warm-up. Dang. Thought I was doing so good. This will never happen again. This homework time in class. Disgusting. Disgusting! Well, it was one of yous. Thank you for understanding me on an emotional level.